this video, we're going to be checking out the top tools and libraries for DeFi and Dapp developers. If you are new to Dapp development, these are the tools and libraries you'll need to get started. Okay, let's get straight into it, starting off with Remix. Remix is one of the most popular IDEs for smart contract development, and it's available on the web at remix.ethereum.org. In here you'll have access to all your files, and when you write a smart contract, you'll be able to build, deploy and test that smart contract straight from Remix. If you're not sure what smart contracts are, that's definitely something you're going to have to research before getting into blockchain development. So anyway, once we've written a smart contract, we can come over to the compiler tab, and you'll immediately have the option to choose from all the various compiler versions. So down here, all you have to do is click the compile button, and there's also an option for auto compilation. The next tab allows us to deploy our contract, and Remix allows you to deploy straight to a virtual machine with plenty of accounts pre-populated with Ether. All you have to do is hit the deploy button, and now you'll be able to open up your contract and interact with it. For example, we can store the number 123 on our contract, and then we can click the retrieve button to retrieve that value. When you submit a transaction, you'll also have the opportunity to debug that transaction. This will open up the debug tab, and we can step through all the various instructions. Remix also offers plenty of plugins for adding more features. Okay, so now we'll move on to the next piece of software, which is MetaMask. You can download the MetaMask browser extension from metamask.io, and if you're on mobile, you can also download the MetaMask browser. MetaMask is an Ethereum wallet, and it implements the Web3 Ethereum API. This means that any websites or apps that support this API will be able to connect up to your MetaMask wallet. For example, we can use Uniswap for trading cryptocurrencies, and all we have to do is hit connect to a wallet, select MetaMask, and click confirm. And just like that, we are connected securely. MetaMask allows us to create various addresses, and we can also connect to whatever chain we'd like. It doesn't have to be Ethereum, and all the test networks are supported as well. You can also sync your MetaMask browser extension wallet with your MetaMask mobile app. Another example of an app that supports the Ethereum API is Remix. So if we come over to the deploy section, we can change our environment to injected Web3, and now we can deploy our contract to a real blockchain. And as you can see, our new contract is viewable on Etherscan. Okay, so now let's move on to the next tool, which is Truffle. Okay, so Truffle is a suite of tools for developing dApps. It is a development environment similar to Remix, except you can use it on the command line, and you can automate everything much better. It also comes with the Ganache blockchain, which is a local development blockchain. You can install Truffle using the Node package manager using the command npm i-g truffle. Once we've done that, we can unbox a sample project. You can use Truffle with any code editor, and I'm using Visual Studio Code in this video. With Truffle, all your contracts are stored in the contracts folder. You can compile all your contracts at once using the Truffle compile command. Next, you'll see a migrations folder which holds scripts for deploying your contract. These scripts are executed in numerical order. For example, here's a script for deploying our contracts. This script will load up two contracts, ConvertLib and Metacoin, and given a deployer, it will deploy the convert library, and then it will link up this convert library to our Metacoin contract, and then finally deploy the Metacoin contract. So as you can see, you have full control over the deploy process for your contracts using JavaScript. So to run all your migration script in a local test blockchain, all you have to do is run the truffle migrate command. Truffle then allows you to enter into this test blockchain and interact with all your smart contracts. But we're going to move on to testing. So as you can see, the final folder we have here is test, and this holds all your test scripts which can be written in Solidity and JavaScript. So the Metacoin contract is a simple token that gives the creator of the contract 10,000 balance. So as you can see in this test script, we are testing that the initial balance after deployment is indeed 10,000. This exact same logic can be seen in the JavaScript version of our tests. So as you can see, there's a lot of freedom for testing with Truffle, and running your tests is as simple as running truffle test. So as you can see, all of our 5 tests have passed. So if you haven't done testing before, testing is essential for smart contracts because once you've deployed a contract, you can't change the code. So if that contract holds any assets, it's crucial that there isn't some horrendous bug. So as you can see, Truffle is a great framework for developing smart contracts, and I've only covered the surface. Okay, so now we're going to move on to some JavaScript libraries for the front end, starting off with the Ethereum API. So I've already touched on the Ethereum Provider API earlier, and I said that the MetaMask extension implements this API. However, some browsers such as the Brave browser support this API natively. You can get documentation for this API at docs.metamask.io. So you can use the MetaMask Detect Provider JavaScript library for connecting up to this API, and from there you'll be able to write code for connecting to someone's wallet. So when we click this button, we'll get a confirmation prompt for adding our wallet address to this website. The RPC API allows you to then communicate with the blockchain. You can send simple transactions using this API, however it gets complicated very quickly when interacting with smart contracts. There are also methods for adding a chain to your MetaMask wallets such as Polygon or Binance Smart Chain, and then you can request for the user to switch over to this new chain. So as you can see, this API is packed with features and works with all EVM based chains, so this means you don't have to write any of the code for interacting with nodes directly. So you'll definitely want to learn everything about this library so that you can get started with blockchain development. So now we'll move on to the final library, which is Web3.js. So the Web3 JavaScript library is a wrapper around an Ethereum provider. So we can plug the provider from the Ethereum Provider API I just showed you into Web3.js, or if you decide to use Web3.js on the back end, then you can plug in your own custom provider. There are plenty of options. Web3.js is primarily useful for interacting with smart contracts, and you are 100% going to be using this library if you are doing that on the front end or on the back end. So you can install this library using npm, and then in your application you'll have to construct an instance of this Web3. To construct this instance, as I've said, you have to pass in a provider. If you are using the provider from the Ethereum Provider API I was talking about earlier, then you can pass this provider directly into Web3. So once you've got your Web3 object, then you can move on to using this library. You can then move on to creating a new contract instance. So this acts as a JavaScript interface to your contract. So for every function in your Solidity contract code, you'll have a corresponding JavaScript function generated using Web3. For Web3 to know what the interface of your contract is supposed to be, you're going to have to pass in your contract ABI, which is a JSON interface. This ABI is generated whenever you build one of your contracts, and if you're using Remix, you can copy this ABI at the bottom of the compilation section. So when you create your contract instance, you'll also want to pass in the address of your deployed contract. So then when you call any of the functions, it will interact with this specific instance. You'll then be able to call your contract functions using call and send. So the difference between call and send is that call is for retrieving data from the blockchain that doesn't require you to submit any transaction to any other nodes. So this is used for all the functions that do not modify the state of the blockchain. However, if you are submitting a transaction that modifies the state of the blockchain, you'll have to use send. So the way this works is you use your contract instance .methods and then the name of your method, and then you can pass in all the parameters for your function. Then you can run call or send and pass in some objects to configure the behavior of that. So anyway, there's a lot more to this library, and this was just an overview. So those are the tools and libraries you're going to want to learn to get into DeFi and Dapp development. So that's going to be all for this video, and if you've enjoyed or learnt anything, don't forget to leave a like. You can see all my other Ethereum related videos on screen now. So thanks for watching, and special thanks to my Patreon supporters who help make these videos possible.